All right, guys. This is section 1.5. This is talking about zeros of a function. Follow along with me. We're going to do lots of algebra today. We have 1.5 left to do. 1.6 and 1.7 I think are together. 1.8, 1.9, then you have your test on September 7th. It's a Tuesday. I will give your quizzes back on Monday. We'll go over them. I'll answer questions if you have them, that sort of thing, so you guys can see how you did. But when we talk about zeros of a function, does anybody know what that means? Don't read to me that for, where f of x are x values for which f of x equals 0. What does that mean? Zeros. Write this down. Zeros, solutions, roots, x-intercepts. Those all mean the same thing. If you ever ask to find the zeros of a function, to find them algebraically, you're going to solve. Lots of times we're going to factor. To find them graphically, this is algebraically, you solve. To find zeros of a function or solutions or roots or anything like that, graphically, you look to see where the graph crosses the x-axis. So the intercepts, where graph crosses x-axis. So it's super easy when I give you a graph and say, where are all the zeros? You literally just look and see where it crosses the x-axis. If you're asked to find the zeros of a function algebraically, then you have to solve. Okay, let's look at these three. Find the zeros of each function. Guys, f of x is a fancy way of saying what? Y. So what we're doing is we're replacing f of x with the number 0, and we're solving. You're setting your equation equal to 0 and solving. So in the first case, I like to have my 0 on the opposite side. So I have 3x squared plus x minus 10 equals 0. Now we're going to do everybody's favorite, factoring. I know, stop being so excited. Calm down. Does anybody remember how to factor? Don't you kind of do something with the A and the C thing? Okay, look, watch. Everyone, lots of teachers teach factoring differently. I'm going to show you how I teach to factor when A is not 1. A is the term in front of x squared, right? So when A is not 1, this is how I factor. If you don't do this, that's okay. As long as mathematically your way is mathematically correct, I'm fine with it. But we need to say A times C. What is 3 times negative 10? Negative 30. Okay. So I have factors of negative 30 that multiply to give me a negative 30, but add to give me 1. 5 and 6. I agree. What kind of a 5 and what kind of a 6? Positive 6 and a negative 5, because I need a positive 1 when I add, all right? So you have x's in the front. Now, this works, guys, when A is not 1. If I were to multiply those two binomials together, x times x would give me x squared. I don't want x squared, I want 3x squared. So when the A term is not 1, in this case it's not, right? It's 3. Put the A term underneath both factors that you found. And simplify. What's 6 divided by 3? 2. Okay. So this is x plus 2. Does 5 divide by 3 real pretty? No. So then this becomes the coefficient. 3x minus 5. That'll work every time. I know some of you were taught with grouping and to writing things. It's the same thing as grouping. It's just written a little differently. But that'll work every time. So now, if we're going to solve, how do you solve this? You set equal to 0. So x plus 2 equals 0. 3x minus 5 equals 0. So my zeros, my solutions, my roots, where this graph crosses the x-axis are at x equals negative 2 and x equals 5/3. You guys agree?
Yes.
Okay. We're going to do lots more factoring. Not much today, but, well, yeah, you will for homework. Yes, sir. All right, here we go. Look at the next one. I have the square root of 10 minus x squared equals 0. How do we solve a square root equation? You square both sides, right? When you square a square root, cancels out. So I have 10 minus x squared equals 0. Now what? Guys? No. How do I get x squared by itself?
Minus 10.
Okay, subtract 10 from both sides. So negative x squared equals negative 10. I heard I would just add 10. You do that. I just always like to have variables on the left-hand side. I get real OCD about weird stuff. Like, it just has to be on the left-hand side. My room is a mess, but x has to be on the left. All right, I need x squared to be positive, so what do we do?
Multiply by -1.
Divide or multiply by -1. Perfect. So x squared equals 10. And now what?
Square root.
Take the square root. So x equals just the square root of 10?
No.
What is it? What goes in front of my...
This 2, 5.
What goes in front of my plus or minus? Very good. When you physically take the square root of something, it's positive and negative. All right, here we go. I'm going to change this to x's because my t's will look like plus signs. How do we solve this, guys?
Don't you multiply the denominator?
Perfect. Multiply both sides. This cancels out. What's 0 times x plus 5? 0. So 2x minus 3 equals 0. X equals what? Move the 3 over. 3 over 2. So what this is saying is that this graph crosses the x-axis how many times? How many x's do you have?
1.
1. So it crosses how many times? Once. How many times does this graph cross the x-axis? How many answers do I have? Twice. How many here? Twice. Okay, good. Good. All right, that's just basic algebra. Yes, sir. Let's scoot along. We've already talked about increasing, decreasing, and constant, so we don't do that. Or this one. All right, average rate of change. When you guys see average rate of change, I want you to think slope. Okay? We use slope, the term slope, when we're talking about a line, a linear function, because slope is the same every single time, right? If your slope is 1/2, from one point to the next, you go up 1 over 2, up 1 over 2, up 1 over 2, right? It's constant. Average rate of change is, you can look at it as the same thing as slope in your mind of how to figure it out, but average rate of change is how much a function changes over an interval of time. The way that you figure this out is super duper easy, right? You cannot look at a graph that is non-linear, like this is not linear. You can't look at this graph and count what the average rate of change is. So what they will always do is they'll give you a function. So this says f of x equals x cubed minus 3x. F of x is a fancy way of saying what? Y. Okay, you need to find the average rate of change, you need the change in y over the change in x's. They're going to give me 2x values. They want to know what the average rate of change is, how much this function changes between the x value of -2 and the x value of -1. Well, if they give me a function and they give me an x value, how can I figure out what the y is? Plug it in. That's all you got to do. So I'm going to say, okay, on the left-hand side here, I'm going to plug in -2. So -2 cubed minus 3 times -2. What is -2 cubed? 8, right? -8 times -8 times -8. I mean, sorry, -2 times -2 times -2.
-8.
Yep. Then I have -3 times -2 would be +6, right? So I get -2. So when I plug in -2 for x, what do I get out for y? -2. Now I'm going to do the same thing, but I'm going to plug in what number? -1. So I have -1 cubed minus 3 times -1. What is -1 cubed? -1. -3 times -1 is, so plus 3. What's -1 plus 3? 2. So when I plug in -1, I get out 2. And now we use the slope formula. X and Y. It's the average rate of change formula. You're going to say, are you guys okay with me saying -2 minus 2?
Yes.
-2 minus 2. And then -2 minus -1. You guys okay with that?
Yes.
Okay. What's -2 minus 2? -4 over -1. What's -4 divided by -1? 4. So my average rate of change for that interval between -2 and -1 is 4. And you can kind of check to make sure that that makes sense. Look, if I go from here to here, what am I doing as I follow this graph? It's increasing. It's going up, right? So that should make sense that your average rate of change is positive. If you would do the same thing and figure out what the average rate of change is from 0 to 1, we would do I'm not going to do it, but we would do the same thing. We'd plug in 0, get a y value. Plug in 1, get a y value. But from here to here, my average rate of change should be what kind of a number? If I go from this point to this point, what should it be? Negative, because it's going down. But average rate of change, the only thing you have to do is they're going to give you the function, the x values. You just plug them in to find y, and then you use the average rate of change formula, which is the same as the slope formula. Does that make sense? Okay. Now we're going to get into odd, even, and neither functions. Did you guys talk about, anybody remember this from last year? Did you get to this? Okay. No problem. We're going to talk about functions, a lot of them. We're going to talk about end behaviors and all this good stuff. But right now, just basic functions, whether they are odd, even, or neither. And you can tell a lot about a function by a lot of things just looking at the equation. But we're going to find algebraically and graphically if a function is odd, even, or neither. Think about even numbers. What are some even numbers? 2, 4, 6. Okay, what are some odd numbers? 1, 3, 5, 7. So a linear function is x to the first power. That's an odd function. A quadratic is x to the second power. That's an even function. A cubic is x to the third power. What kind of a function do you think that is? Odd. Good. Depending upon the exponent. Now, not all cubic functions are odd, but they can either be odd or neither depending upon what's going on with them. And we'll get into a lot of that later. But just the idea of even and odd. Think of the actual numbers, even and odd numbers, and then we're going to talk about directions of arrows and stuff like that. This right here is what I'm about to talk about, but I'm going to talk to you about it in high school terms, okay? If you're given an equation and it says determine algebraically if a function is odd, even, or neither. I want you guys to write this down. Write down the word even. It's even exponent. Same answer. And I'll show you what I mean by that in a second. And if a function is odd, it'll have an odd exponent. And it'll be opposite answers. Now the books will tell you to plug in x and negative x and then compare the answers. That can be extremely confusing. Extremely confusing. So I'm going to show you a trick that will work every single time. Okay? We're going to test two numbers. Any number and its exact opposite. It just has to be bigger than 1. So you can do 2, 3, 7, 12, whatever. It doesn't matter. It just has to be the number and its exact opposite. And we're going to plug it into the function. And then we're going to look at the answers, if they're exactly the same, if they're exact opposites, or if they're just nothing completely to do with each other. It'll tell us all the information we need to know. So the first thing we're going to do, let's write down our function. It says f of x equals x cubed minus x. Odd, even, neither. All right, those are our three options. But right away, you can take away one of the options. Look at the highest exponent. What is the highest exponent? 3. It's an odd number. So the only possibilities that this function could be are odd or neither. It cannot be an even function because the highest exponent is an odd number. So now we're going to set up our problem. And this is how I want you guys to do these. And you'll see it really is easy, I promise. What did I tell you that odd functions have for their answer? Opposite. I want you to write the word opposite right here. This will make sense in 1 second. Now let's pick any number greater than 1. And its exact opposite. Okay, so I'm going to say 2 and negative 2. I want somebody else to do this with 3 and negative 3. Okay? Now just substitute in your number. 2 cubed minus 2. Just plug it in for our x value. What is 2 cubed? 8. What's 8 minus 2? 6. Okay? Now I'm going to plug in negative 2 cubed. So it's negative 2 cubed minus negative 2. Make sure you get your sign right. So I have negative 8 plus 2, right? What's negative 8 plus 2? Negative 6. Are those two numbers opposites?
Yes.
Yes, then you just proved that your function is odd. If they were not opposites, if you got 6 and 12, what would your answer be? Neither. Did someone work that out using 3?
Yeah.
What'd you get for your answers?
24 and negative 24.
24, negative 24. The number itself, guys, doesn't matter because if you choose a different number, you're going to get a different answer. It's the relationship that the two answers have to each other. Does that make sense? Okay, let's try another one. X squared plus 1. Okay, first of all, let's determine what our two possibilities could be. It's an even number, so this could either be even or neither. What number do we want to use?
4.
Okay, 4, negative 4. You guys ask me, how can I show my work? I'm showing you. What word should I put in between those two boxes if I think it might be even? Same. So let's plug in. I have 4. I would use parentheses as much as possible. 4 squared plus 1. Plus 1 is 17, okay? Now I'm going to come over here and say negative 4 squared plus 1. 16 plus 1 is 17. What'd you just prove to me?
It's even.
It's even. Now what I do want to bring to your attention, okay, just say, because we're all going to pick different numbers. Some of you are going to be like, I want to do 12. Fine. I don't want to cube 12. So I always do 2 and negative 2. Sometimes 3 and negative 3. But just say, right, just say you have this random function. I'm just writing this down. It doesn't mean anything. All right, and you're going to figure out if this is odd, even, or neither. This is why I think this is so important that you guys set it up like this. Okay? What are my two options right here? If I think it's okay, even or neither. What word do I put? I don't know why I put that. What number do I put in between my two boxes? Same. So just say this random function in whatever number I pick, I work it out and I get like negative 7 and positive 7. You guys are going to be like, oh, it's odd. Is it possible that this is an odd function? No, because the highest exponent is an even number. That's why I say it's so important to write the word in between here. Just say it works out that you got opposite answers. You have to look at the relationship between the answers and say, I think it's even, so are they the same? Are those two numbers the same?
No.
So then your answer here would be, oh, it's neither. An even numbered, like an even exponent, can never be an odd function, or vice versa. So once you determine whether it's could possibly be even or could possibly be odd, you need to just keep that in your mind that it has to be the same answer or opposites. And we'll go through some more, I promise. Now, after I talk to you about this for 3 seconds, you're going to be like, man, can we have 20 of these on our next test? If I give you a graph and I say, is this odd, even, or neither, right? If it's an even function, what did I tell you about the answers of an even function? They were the same answers, okay? An even function on a graph, the arrows will go in the same direction. Okay? They have to be in both of these things. Same direction, and it has to be symmetric to the y-axis. Somebody first here is like, oh, I remember that word, but not really. That means the y-axis has to do what? Cut the graph in half. All right, if I think it could be an odd function, the arrows are going to go in what kind of direction you think? Opposite, good. And instead of being symmetric, D-I-R-E, to the y, it has to go through the origin. It's symmetric to the origin, but it's got to go through the origin. So it has to do both of those things. So if you're given a picture and it says, is this function odd, even, or neither? You look at the ends of the arrows. These arrows are going in what direction? The same or opposite? Opposite. And does it go through the origin?
Yes.
So then this is an odd function. Look at this one. End of the arrows. Same direction? Yes? Does the y-axis cut it in half?
Yes.
Then it's even. If it doesn't do both of those things, then it's neither. So algebraically and graphically, they go hand in hand. You think even is same, odd is opposite. So if we look at some examples here, let's do these together, and then you guys will have time to get your homework going. I can give out yearbooks. Let's look at 6, 7, and 8. Graphically, are these odd, even, or neither? Let's look at the ends of the arrows. Same direction or opposite direction?
Same.
Same. Does the y-axis cut this in half?
Yes.
So this function is? Even. Good. Next one. Direction of the arrows are?
Opposite.
Opposite. Does it go through the origin?
No.
So this is?
Neither.
Perfect. Look at the next one. Look at the direction of the arrows.
Opposite.
Opposite. Does it go through the origin?
Yes.
So what is this?
Odd.
Odd. Would you like a bunch of those on your next test?
Yes.
Chances are slim to none. Maybe I'll give you one little layup. All right, let's do these together. This is how I expect to see your homework. This is what I want you guys to practice getting in the habit of doing, because this is really a fairly simple process. It's not the easiest concept, but the process is pretty simple. You have to first determine what is the highest exponent. Is it odd or even? So my choices are, this is an either odd function or a neither function, correct? Okay, so when I think of odd, I think the relationship between my answers, they should be what of each other? Opposite. Any number you want, I don't care. I'm going to go with 2 and -2. Sean, you with me, babe? 2 cubed minus 6 times 2. What is 2 cubed? 8. What is 8 minus 12? -4. Don't skip steps on this either, guys. Really easy to make a silly mathematical error. So now I have -2 cubed minus 6 times -2. What is -2 cubed? negative 8, and then I have plus 12, right? What's negative 8 plus 12? 4. Look at these two numbers. Are they opposites of each other?
Yes.
So then your function is odd. So if we graphed it, the arrows would be going in opposite directions, and it would also pass through the
Origin.
perfect. Good job, guys. It's a good Friday. Okay, look, I have two exponents here. Which one do I look at?
The highest.
The highest one, the biggest one, okay? So, what are my two choices here?
Even and neither.
Even and neither. Let's do 2 again. What are my answers, the relationship going to be? Same. So I have 2 to the 4th power minus 2 times 2 to the 3rd power. What's 2 to the 4th power? 16. 16. And then 2 cubed, then what?
8 times -2.
Which is?
-16.
So what's 16 minus 16?
0.
Now I have negative 2 to the 4th power minus 2 times negative 2 cubed, right? What's negative 2 to the 4th power?
-16.
No, positive 16, right?
Yeah.
And then negative 2 cubed is negative 8 times negative 2 is positive 16. What's 16 plus 16?
32.
Are those two answers the same?
No.
So what's my function?
Neither.
Neither. Be careful, guys. That would have been really easy to just go, oh, it's probably minus 16, right? Just be careful. Change this to x squared. I don't know what happened to it. But what do we think this might be?
Even.
Even or neither. All right, let's do 3. What do I know the relationship of the answer should be if it's even? The same. So 3 squared plus 2 times 3 plus 1. What's 3 squared? 9 plus 6 plus 1. What's 9 plus 6?
15.
Plus 1 is 16. Good. So negative 3 squared plus 2 times negative 3 plus 1. What's negative 3 squared?
9.
9 minus 6 plus 1, right? Agreed?
Yes.
What's 9 minus 6?
3.
And 3 plus 1 is?
4.
Are those two numbers the same?
No.
My function is neither. Does this make sense?
Yes.
All right, I want to do these last two. I'm going to do one of them. I'll do both of them with letters in a second, but let's just do it with numbers so I can show you why I think this is easier to use numbers and how we're still doing the same thing as if you were to use x and negative x. What are the possibilities here?
Even and neither.
Even. Whoa. Sorry. Even or neither. So what number do you want to use? 5. And negative 5. What is the relationship between the two answers? Same. All right, well, 5 squared plus 6. What's 5 squared?
5.
Plus 6 is?
31.
What is negative 5 squared
25.
plus 6? What'd you guys just prove to be?
It's even.
Even. Two and negative 2? What are my two possibilities?
Even.
Odd or neither? What are the relationship between the two answers? They have to be opposites in order for it to be an odd function. So I have 2 times 2 cubed plus 7. What's 2 cubed? 8. And 8 times 2 is?
16.
What's 16 plus 7? 23. Now we're going to do with negative 2. What's negative 2 cubed?
-8.
Negative 8 times 2 is Negative 16 plus 7 is negative 9. Are those two things opposite?
No.
Nope. So my answer is
Neither.
neither. Now, real quick, let me just show you. You guys ever look this up on like Khan Academy or something, and they're doing odd, even, neither algebraically? They're going to plug in, like I said, x and negative x and then compare. So look at here. I just have like my grandpa. Look at here. If you, excuse me, say we plugged in x and negative x. My function is x squared plus 6, right? So I'm plugging in x. So x squared plus 6. Now I plug in negative x. Negative x squared plus 6. What is negative x squared? What's negative x times negative x?
X.
X what?
X squared.
X squared plus 6. So compare these two. Are they the same?
Neither.
So that makes it even. I just think it's so much easier to use numbers. Very easily you guys can get yourselves confused, especially in something like this, right? I think this might be odd. So if it's odd, they have to be what of each other?
Opposite.
Opposite. So I have 2x cubed plus 7, all right? I'm going to plug in x. I'm going to plug in negative x. So when I plug in x, I get 2x cubed plus 7, right? When I plug in negative x, 2 negative x cubed plus 7. What is negative x cubed?
Negative.
Negative x cubed. So this would be negative 2x cubed plus 7. Are these two are opposites of each other?
Yeah.
Are they complete opposites of each other?
No.
If it was a complete opposite, it would be negative 2x cubed minus 7, right? The first parts are opposites, which, look, when we did it algebraically, positive 16, negative 16, right? But the back is the same, which is exactly what we have here, right? So you're doing the exact same thing of plugging in x and negative x. You're doing that in this problem. It's just so much easier, I think, for us to wrap our head around and to see if you use numbers. Because you're not, the answer itself, the numerical answer, God bless you, that you get is not what you're looking at. You're looking at the relationship between the two answers. Does that make sense? Are you guys okay? All right, I will upload this in just a second.